ठीक सर, अल्हम्दुलिल्लाह खैरियत।
Are you fine? Okay. So is my screen shared with you?
यस सर।
Yes, sir.
Yes. Mohsin का paper मुझे receive हुआ है. So we will be discussing. Yeah. Okay. Yahya is also there in the class, right? Yahya.
Yes, sir.
Okay. So I am waiting for your papers after solution. So please submit it to me as soon as possible. Yani, hopefully today.
Yes, sir.
Will it be possible for you?
Yeah, totally.
Inshallah. Okay. So we are going to have a quick revision of your kinematics. And in kinematics, we have two main topics actually, but they are further divided into, for example, here multiple topics mean projectile motion. So equation of motion, graph, and projectile motion. So I will talk about this in detail. Okay. Here we go. Okay, so when we talk about kinematics, actually, in kinematics, the situation is for your quick review. I would, as I have earlier told you, that we will divide this topic into three main categories, right? That is basically uh, the motion, some sort of equations of motion, some terms involved, then graphical analysis, and then projectile motion. Okay, I mean, in that one, I will add the free fall as well. So first of all, when we will talk about the terms which are being discussed in your kinematics, they are distance, displacement, speed, velocity, acceleration, deceleration, as etc. Free acceleration of free fall and onward. And some other areas are the equations of motion. They are SUVAT equations, yani displacement, distance, initial speed, final speed, or velocity, acceleration, and time equations. And then we will talk about the graphical analysis. In graphical analysis, we will talk that how these all equations are being used in different areas. And then projectile motion is a complete topic which is based on, mostly based on the graphical sorry projectile sorry equations of motion, but some parts are there which are discussed with the help of the graphs. So starting with that, very quickly, you people have a lot of information about this distance, displacement, etc, etc. I will just give you a quick review. That distance is what total path length traveled in any direction. It can never be negative, and it is always additive. If you take one step in whatever the direction is taking, yani you are going towards the home or you are moving away from the home, your distance is always added. So it is just like treated just like numbers. It is a scalar quantity. And then when we talk about displacement, displacement is basically that type of quantity which is vector. So it is the shortest distance between 2 points. Yani, if the distance from A to B is this one, then A to B prime is this one, then the displacement is this part. Yani, this is that displacement, right? Between B and B part, and B bar. So it is basically in a straight line. And second, third, it has a direction dependent hota hai. And it can be positive, it can be negative. Positive displacement can be in any direction. Usually we take the positive displacement when the body is moving away from uh, the starting point or moving upwards, and negative is taken when it is moving towards or moving downwards, or moving left is taken as negative and moving right is usually taken as positive. So these conditions can be changed according to the situation, but generally we say that. Then it can be subtracted, because yani, if it is negative, then it can be subtracted, though it can also be zero. Why? When the body is moving in a closed path, displacement can be zero, because body is moving back to the original position. So remember this thing, that in all type of situations in which the body is moving in a closed path, I mean the body is coming back to the original position, displacement would go to zero, right? Is this very clear to everyone? Hello, do you people hear me?
यस सर,
Yes,
क्लियर है।
sir. That's clear.
Okay, so displacement is just like treated like vectors. So देखो, in vector rules you have to be asked, displacement can be resolved, it, its the resultant can be taken, sine rules can be applied on that, cosine rules can be applied on that, Pythagoras theorem can be applied on that, so and so and so. So all the things what you have learned in your vectors, they all is applied on the displacement. Then we will talk about the speeds. So speed is just like scalar, distance covered per unit time. It is for calculation. It's usually it is made into meter per second, and somehow it is made into kilometer per hour. But the calculations are really important. Calculations, they are, the average speed is total distance divided by total time taken. What is average speed? Total distance divided by total time taken. And one more thing what I want to, because you are you people are in the crash course, so you must now the conversion of displace meter per second into kilometer per hour and vice versa. For kilometer per hour to meter per second, I just have a short trick for you. Just multiply the unit or divide by unit by 3.6. So for example, sorry, here, if you are going to convert kilometer per hour into meter per second, you will divide the number by 3.6. Why? Here is the entire discussion. Kilometer has 1000 meters and hour have as 100, sorry, 3600 seconds. So it would be 1000 divided by 3600. So it is actually in meter per second. So if I have written just one example, 120 kilometer per hour, it means you are driving at a speed of 33 meter per second. Or if I say that you are driving at a speed of 20 meter per second, that is the conversion what I have made here. 20 meter per second means 72 divided by 3.6, it will give you 20 meter per second. But 20 meter per second into 3.6 gave you 72 kilometers per hour. Is it clear to all? Is it clear?
Yes, sir. It's clear.
Okay, so you have to keep this point in your mind. Yani, just simple idea. And furthermore, when we talk about the velocity, it is actually the rate of change. So rate of change means it have sorry, rate of change of displacement, not rate of change only, rate of change of displacement. So when we have to consider the rate of change of displacement, it is vector quantity by law. It means it will have magnitudes and direction. Just see this slide. It has magnitude and direction. Yani, this is the magnitude of speed and theta is the direction. So if the magnitude is not changing, here there are three conditions: black, red, and green. Black is that when magnitude remains same, direction is changes only. So here only direction changes. What happens? Only direction changes. Here only magnitude change. So change in magnitude. Here both change. Is this clear to all?
Yeah.
Yes, sir.
Okay. So change in direction. So in all these cases, velocity would be changed. So mostly there are some questions. There are yani several questions in which we have to take velocity as a vector, and this is a question that an aeroplane is moving at a speed of, let's say, or a swimmer is moving at a speed of 8 meter per second, and then um the stream or the water flows from west to east or east to west with the speed of 4 meter per second. So what is the resultant velocity formed by the influence of the water? So we will use either sine rule, cosine rule, resolving, or combination of the vectors. All the rules what we have learned for the vectors, they all can be applied over there, right? Usually, one question which is very famous, that an aeroplane is moving the speed of 720 kilometer per hour, and a wind is blowing from west to east. So to keep the aeroplane in the right direction, where should the pilot steer the aeroplane? Right. So these type of questions are basically, they are referring uh, the vector nature of your velocity. Okay.
Okay.
अब problem ये है कि when we will go to the acceleration is basically an extract of velocity. So acceleration is rate of change of velocity. So rate of change of velocity, it is asked to you for 1 mark. It's very, old fashioned story, that acceleration is velocity, change in velocity per unit time. So you can write it, no issue at all. But it gives you the defining equation of acceleration, that is delta v by t. And secondly, it is v minus u divided by t. Or in other words, if you just keep this equation in this way, that delta v is equals to at, This is the first equation which will give you the analysis of your speed, initial speed, final speed, and time taken and acceleration. So change in velocity can be taken as, yeah, here is that important question. This is again a past paper question, what I have explained here in the topic, that your change in velocity is what? A into d. If you just see it from this diagram, what is change in velocity? It is A into d. Is it? Do you believe this thing?
Yes, sir.
Okay, so let's say this question was asked in your past paper, that u is the initial velocity and v is the final velocity of the object in this direction, right? And what is the this vector, this pink vector? So as you know that by the rule of addition of vector, if I have 20 meter per second speed and now I am moving with a speed of 25 meter per second, what does it mean? How much change I got? I got a change of 5 meter per second, isn't it? Do you agree?
Yes.
So if I want to find the final one, what does it mean? That the final speed is initial plus change. Initial speed, it was 20, so it was 5. So that is why it became 25. So it means by using the number rule, I told you the resultant is the final velocity. So if I just apply that in equation, u is equal to at plus v, or v is equal to u plus at, then at is the difference of these two velocities. So it means if I say that this change, that is equals to v into, sorry, v plus at, yeah, v plus u, sorry, this change is u, sorry man, v minus u is change, na? V minus u is change. So what will be the final situation here? Isn't it change in velocity? Is it na? So it means delta v is equals to change in velocity. We have learned that it is equals to 80. Got it? So sometimes you people are asked about this. Then secondly, if you know that here is that what I have explained in detail, no worries at all. Simple. Then we will go to the equations of motion, the second aspect, and which is the more vital aspect of your kinematics is actually these are the equations of the motion, SUVAT. R- There is only yani, if you will recall the equations, they will help you out. No derivation included in the equations. Yani equation की derivation नहीं है. And if the derivation is not included, then you people can have simply recall them, and uh, recall is a sort of situation in which some of the equations are given to you in your data booklet. For example, this equation is given to you, right? This equation is with you from your, you know, childhood. The only thing which is left over, that is third equation, v is equals to u plus, sorry, 2s is equals to u plus 80, isn't it?
Yes, sir.
Yes.
So that equation, yani these three equations rather, these equations are the equations which will help you out to figure out all the problems, almost all the problems which are included or which are involved in your kinematics. Yani every problem can be solved with either single equation or by combining the equations. So these equations are mandatory for you. Simply I will say mandatory for you. When there is a is v is equal to u plus at is used when acceleration is taking place. S is equal to ut plus 1 by 2 at is in case of acceleration. I have written in box that in case of acceleration. Then the second part of this equation, which was not early mentioned in this, it is that's why it is 2a and 2b. So S is equals to vt minus 1 by 2 at square. That is why if your initial speed goes to 0, you can use the blue equation, and if you have final speed 0, you will use this red or pink equation. Then third one, 2s is equal to v square minus u square. Then in case of no acceleration, you will simply use s is equals to ut or v is equals to d is equals to vt. It is really common equation, I think so. From your O levels or IGCSE or your previous level, you have learned this equation, isn't it? That D is equals to VT or S is equals to
Yeah.
VT. Okay, so that is why when we talk about this, that what is described in it, S distance or displacement, U can be initial speed or final speed, sorry, initial speed or velocity, V is final speed or velocity, then T is the time taken. So in this way, A is acceleration. Then there is a game of relative equations. If you just don't forget this concept of relative equations, relative velocity, you will have yani you will be having a very great concept here. You will have very precise concept of motion with respect to each other. Okay, देखो, there is one situation, and that is the velocity of one object with respect to other. For example, if mass 1 is moving with the speed of 30 meter per second, its velocity is considered as 10 u1, and there is mass 2 ball 2, it is moving with the speed of or velocity of 20 meter per second in the same direction, then its velocity is considered as u2. So can anybody tell me what is this, yani how much faster object m1 as compared to that object m2?
10 meters per second.
10 meters per second. Simply, that is why we call it relative velocity, the velocity of one object with respect to the other. That is why if you simply say that if one object is moving with lower velocity, and the object which is chasing it, if it has the velocity or more velocity, then this would be create a case of approaching. Right here it is approaching velocity. Relative approaching velocity is the velocity by which the object approaches. So remember this thing, simply speaking, simply, because I'm just going to give you the um, the extract of kinematics. That's why when two bodies are moving in opposite direction, their relative velocity is sum of velocities. And if two bodies are moving in the same direction, their relative velocity is difference of velocities. Greater minus smaller. Greater minus smaller. Got it?
Okay.
So if I simply say that these velocities are, for example, this was a case in approach. Two bodies, these two blue bodies are moving towards each other, so they will approach towards, right? That's why it is written relative approaching velocity. This is the case in which m2 is slower than m1. Again, it would be approached. That's why it is relative approaching velocity. So in both the cases, relative approaching velocity is there, but for same direction negative, and for opposite direction it will be added together. Then in case of separation, if your body which is yani ahead, if it is faster, then it would be separation case, right? Separation, m2 is separating out by m1 by a speed of 10 meter per second. Then the same case is applied if both the bodies are moving in the same direction, but they are separating. Their rsv, relative separation velocity, is difference of both the velocities. But when they are moving in opposite direction, their relative velocities are sum. So finally, this is the statement: relative velocity is difference of velocities for same direction, and for opposite direction it is, yani relative velocity is sum of velocities. Is this very clear to everyone?
Yes, sir.
Yes, sir.
Okay, so there are some questions which can be solved by this all. Uh, this is one of the questions. It has different approaches, by the way, yani different equations of motion. So let's have a practice of this question. Let's say from different aspects. For example, this question is a bit horrible question. What I have selected for your discussion: the car moves with a uniform acceleration. Uniform acceleration. You do not know what was the acceleration, but that moves with a uniform acceleration in a straight road. On a straight road, oil leaks from the car at the rate of one drop every 2 seconds. One drop after 2 seconds. The diagram shows the distance between three successive oil drops, yani consecutive oil drops. So you can simply consider that there are three oil drops, and these three oil drops, one is over here, the second one is over here, and third is over here, right? So when time starts, yani when you have noticed the mm, dripping of oil, then the car was not from starting from rest. The car was moving, and till the second drop has been dripped out, the car's speed was something different because it is accelerating, and for third it is something different because again it is accelerating. But the only common thing is the interval, time interval you have made, they are of 2 seconds each, and for every distance traveled after every droplet, that is 9 and 12 meters. So it is asked, what is the acceleration of the car? This question has different approaches. It's an MCQ, so no working is required, but the right approach is required. For that one, for example, if I go to this solution, that acceleration is delta v by delta t, delta v by delta t, right? Being a student, I will start right from here, na? By defining equation here, sir, acceleration is delta v by t. So delta v, I have to find that what is the change in velocity. For example, if I say that um, from time t is equals to 0, the object has velocity v1, and at time t is equals to 2, object has velocity v2, then the distance traveled is equals to how much? 9 meter per second. So what can be the velocity v2? I mean, after this, after 2 seconds, I have to find out this one, right? So if a student is applying this concept that s is equals to vt or d is equals to vt, so 9 meter is the distance travel, so final velocity will be equal to this into 2 seconds. So v2, that is equals to 4.5 meter per second. So this is entirely a wrong approach. The reason, Mustabshir, can you tell me the reason?
सर मैं तो इसी तरीके से करने का सोच रहा था.
Yes, that's why I have started this. Sorry, I have started from this idea that student's approach is rate of change of velocity, and the what is wrong in this student approach, that the student has not used the concept of acceleration. What did the student do actually? The student did the game of what?
सर एक सेकंड, मुझे लग रहा है कि
Mhm.
मतलब मुझे लगा कि आप कह रहे हैं कि इस तरीके से आंसर निकालना शुरू करना ही गलत है. ये अभी ये वेलोसिटी निकाल के फिर दूसरी वेलोसिटी निकाल के फिर उस तरीके से मैं करने
Mhm.
का सोच रहा था.
Okay, okay, yes, yes. The same approach is by the student. देखो ना, the same thing I have done. V3, V3 is what? V3 is in from V2 to V3. What is the total distance traveled? It is 12 meters. And how much time is taken? 2 seconds. So it means V3 will be 3 meters per second. Is it?
यस.
So when you are going to take this, yani acceleration is V3 minus V2 divided by time taken. So V3 is this much. V3 is what? V3 is your 6. V2 is your 4, 4.5. So 6 minus 4.5. And what is the time interval between these two? That is 2. So answer is 0.75 meter per second. And that is the right option. But the problem is this is not the right approach. If the same type of question is to show that question, or if the same question is the numerical problem question that find this acceleration, then you people would get 0. Why? You have violated the basic physics. And what is the basic physics? That, as I told you here, exactly at this point, if you don't forget my instructions, exactly at this point I told you that this all will be used when acceleration is equal to 0. Are you getting my point?
या.
So when acceleration is 0, then you can apply it. But how acceleration is 0 where we are going to find the acceleration? Am I right?
Yes,
Are you
sir.
people getting my point? That actually the acceleration is not equal to zero, and that is what you are going to find out. But you are using the concept of zero acceleration, that a body is moving with a constant speed. That's why this approach is incorrect. So for this purpose, what will you do? You will try to figure it out analytically, and that analytic approach is in first half. Let's say your initial velocity, as I told you, that the body did not start from zero, so its initial velocity is something. Let's say it is v1, and then let's say it is v2. So it has moved a distance of 9 meter in 2 seconds, and it's, let's say, its acceleration is a. Everyone agreed with that or not? So I will use this equation, that s is equals to ut plus 1 by 2 at square. S is equals to 9. U is basically v1, because I have started right from here. Am I right? And time is 2 seconds. Again, acceleration is a. So I made one equation, or I got one equation. Okay. Is it, is there any confusion?
No, sir.
Okay, so you got this equation linearly. Then for second half, where the object has traveled 12 meters in next 2 seconds and acceleration is again a. But what if I start right from here again, and I till approach to this point? So s is equal to ut plus 1 by 2 at square is the equation. Now the total distance traveled in 4 seconds. The important thing, in 4 seconds, is how much? 21 meters. Yani starting from v1 to v3, that is what, 21 seconds, 21 meters. So I use that. 21 meters is equal to v1 into 4 plus 1 by 2 at square. Time is now 4 seconds. So you got another equation. Just subtract these two equations, and when you are going to subtract these two equations, I mean, probably you will get 2a equals to 1.5 and a is equals to 0.75 meter per second. So this is the right approach. Why I have selected this question, that with a wrong approach you can get a true answer, but the problem is that is just a good luck. Do you believe this thing, that what a good luck is? Hmm?
Yes, okay.
Okay. Yes. So by luck, the student can get this this answer, right answer. Afterwards, yes.
सर फिर मतलब कोई और प्रॉब्लम होती तो इस तरह आंसर नहीं आ सकता था जो हमने तरीका लगाया?
Agar it would be by
यानी
the
सर वैल्यू चेंज हो,
situation. Yes.
वैल्यू चेंज होती।
No. 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 Value change is that, then it was not possible. Any option is given to you, definitely. है ना?
जी सर।
Option, if it would not, yani if the wrong option is given in the, yani if the right option is given by wrong calculations, yani for example, if it is possible, sometimes it is possible, but all the times it is not. That's why I'm saying that you have to focus on the right physics.
जी सर,
Okay, is this clear to all?
क्लियर।
Okay.
Anyone else? Is there any problem, or is there any confusion with anyone else?
No, sir.
Okay, so these are some sort of questions. I mean, these are some sort of ideas. And one more thing, no worries at all when you are having a free fall question. Only in that case, sorry, only the thing what you have to change, that is the value of a would be replaced by value of g. And secondly, you have to take care of one or two points which are very important here, that what you have to hunt, that either the resistance is negligible or not. If resistance is negligible, then the body will move with a constant acceleration, gravitational acceleration. And if not, then it would be mentioned. Then second thing, you have to hunt whether the body is moving upward or downward. If the body is being dropped, if you have this word uh, in your description, it means in all these cases the initial velocity will be zero. Initial velocity will be zero. And if a body is thrown upward, definitely without throwing, you cannot send a body in the upward. So in that case, your final velocity will be equal to zero. What will happen? Your final velocity will go to zero. Is this all clear? So the
Yes, sir.
equations of motion, what will be used, that v is equals to u plus at. I mean, that is changed. V is equals to u plus gt will be for upward motion, and v is equals to u minus gt, that will be for downward motion. But simply speaking, for downward motion, acceleration is taking place, g is positive, and that is why you will consider this all. Okay, whatever the motion is, if you are taking if you are considering the free fall, then your final speed or initial speed is a into t or g into t, simply speaking. Then in the second case, when distance is mentioned, yani in this one, distance or the height is not given to you, right? Distance or height is not given to you. Here, your either initial speed or final speed is given to you. So you will use that equation, s is equal to ut plus 1 by 2 at square. If you just keep this u goes to 0, then what will happen? This all will be gone. Yani u will be 0. Okay, u will be 0. U will be 0 mean here the height is, ut plus 1 by 2 gt square, or the height is vt minus 1 by 2 gt square. These are the 2 points for your consideration. So if the body is dropped, as I told you, this would be gone. So equation shrinks to g, h is equals to 1 by 2 gt square. And if the final speed is 0, yani if the body is just thrown, then it would decelerate. So this negative and this negative will make it positive. So again, the equation will shrink to 1 by 2 gt square, right? So these all equations are really, really helpful to find out the relations of height and time, height and velocity, and all that. So you have to keep these points in your mind, that the equation which is 2gh is equals to v square minus u square, that is 2g is equals to u square if your v is 0, and 2gh is equal to v square if u is 0. So in any case, one of the velocity and divided by 2g will give you height. It's really, really simple game, right? Is there any confusion in this part?
No, sir. It's clear.
Okay, good. So, inshallah, in next part, we will be discussing graphs and furthermore projectile motion. Inshallah, I will try my best to complete these two both.